テレビ東京ロンドン支局のトム・シーザーです。From inside the Financial Times headquarters in the heart of the city of London, this is Inside FT, brought to you by TV Tokyo. Here's today's headline. Data centers look to tap UK gas pipelines to meet power demands. UK data centers are consuming so much energy that some operators are even considering direct connections to the country's gas pipelines. We sat down with Tim Bradshaw, the FT's Global Tech Correspondent, to discuss why AI's explosive growth is straining the national grid, what's driving this unprecedented race for power, and whether gas can really provide a long-term solution.
There is a huge wave of investment in data centers happening all over the world right now to tap both exploding demand for artificial intelligence applications like ChatGPT, to train the next wave of AI models, and to plan for what big tech companies believe will be even greater usage of AI services in the years to come. And one of the key limitations on that expansion program of data centers is power. It is really, really hard to find energy in sufficient quantities to power these very energy-hungry data centers. So what we're hearing about in the UK is that several tech companies have approached National Gas, which provides the gas transmission pipelines that are really the backbone of the gas system in the UK, to try and tap those directly to build gas-fired power stations, small gas-fired power stations, just for a single data center. And I mean, this is really an extraordinary development. It's still in its early stages. These are not deals that have been signed, but even the data center companies are believing that they need to go straight to the energy backbone, that the grid itself doesn't have the available capacity, or that there are not clean energy sources that they can use, which might be much more environmentally friendly, as a lot of these companies tries to be. But like, and again, this is not we're not talking about the gas distribution network that sort of runs to normal homes and businesses and offices. This is the backbone. This is going straight into the main line, and so it's really an indication of just the really unusual nature and the speed and the scale with which people are trying to bring this new data center capacity online. Most of the demand for AI infrastructure is coming from 5 or 10 companies really around the world. There's the likes of Microsoft, Meta, Google, OpenAI, of course, and then their rivals in Asia like ByteDance, Tencent, Alibaba. And so they are all working with building the data centers themselves, but also working with a large number of new cloud providers that have popped up. CoreWeave is perhaps the most prominent example in the US. But in other parts of the world, there's companies like Nebius, and Nscale is a big one that's coming up in the UK. And these are businesses that were really quite small even a couple of years ago, that are now worth tens of billions of dollars. And so we don't know which of those are actually going to sign any of these contracts, and it's National Gas, which is owned by Macquarie, an asset manager, is saying these talks are still at the nascent stage. But again, I think what's interesting about it is that the tech companies that ultimately will be buying this AI capacity are just desperate to find energy wherever they can. The kinds of data centers that we're talking about for AI are really a very different beast to the kinds of data centers that have been a familiar part of the tech industry for decades now. Amazon Web Services, when it started up 20-odd years ago, was really helping companies stand up websites and host applications. This was running databases, using basic Intel chips, CPUs, the kinds of computers that you would see under desks in offices, but just filled into data centers. The servers were running on very similar standard computing infrastructure. What we're seeing now in AI is because so much of that processing is so data intensive, you need a different class of chip, which is currently provided almost exclusively by NVIDIA, and a couple of others like AMD are trying to catch them up, but the gap is very wide. These NVIDIA chips originally started out as graphics processing units for video games and developing animated movies, and that's because while the Intel chips that ran in data centers traditionally are good at doing a lot of different tasks, the NVIDIA GPU is just good at doing one thing over and over again, and that's great for AI. The type of calculations, the type of algorithms that AI runs is really suited to that chip. And those chips are just much more energy intensive than what came before because they're doing all of that processing in parallel. So you're running lots of calculations at the same time. The calculations that a traditional CPU would run is more in sequence, it's one at a time. And so that causes them to be much more energy intensive. And people are stacking, it started with thousands, it then went to tens of thousands, we're now talking about hundreds of thousands of GPUs in a single data center or a single cluster of data centers. And it's an extraordinary amount of power for a single facility that's orders of magnitude more than what we'd have seen in a traditional data center from AWS or Microsoft Azure in even a decade ago. The GPUs themselves consume a lot more power than traditional data center chips, but they also give off a lot more heat because they're working a lot harder. And so particularly the new generation of NVIDIA chips called Blackwell, which is just coming online now, get too hot even to be cooled with air conditioning. They need liquid cooling. That liquid has to run through the data center and is then has to be cooled itself before it's reused. So it's not just the chips, but all of the cooling infrastructure around it, again, just adds to that energy pull, and hence why their operators are looking for novel sources of power. And I think in total, the International Energy Agency has predicted that data center capacity or energy requirements are set to double by 2030 to something roughly equivalent to the entire energy demands of Japan today. Just for data centers around the world. I mean, these are mind-boggling numbers. The UK government is desperate to attract more of these AI facilities to the UK at the moment. Compared to the US and China, Britain is far behind in having the capacity to train big new AI models, and therefore the UK lacks a sort of native sovereign AI capability, both in terms of the technology that runs it or the infrastructure to deploy it on.